Okay, so here is the review for the next test. All right, number 1 says to solve algebraically. So notice it's a rational equation. Remember, the goal is to always get these two denominators to be a 1. All right, so we have 2 over x plus 3 over 5x equals 1. If you want to make the 1 a fraction, just put it over 1. So say to yourself, what do I need up top so this 5 becomes a 1? So I need a 5. Make sure you multiply all the numerators by 5. And then I need to make the x's become a 1, so I need to multiply everything by 5x. So now I'm going to reduce. So x and x reduce, so I'm left with 10 here, plus 5x and 5x reduce, so I'm left with just 3, equals nothing reduces here at the end, so I'm left with 5x. Combine like terms, 13 equals 5x. Divide by 5, x is equal to 13 fifths. And you should check it, okay? Will tell you though that this does work. Okay, so let's take a look at the next one. Number 2. So number 2 says to find the zeros and state the factors. All right, so I have f of x is equal to 3x squared minus 24x plus 21. All right, so I want to find the zeros. That's when my function is equal to 0. And I notice there is a GCF, so I'm going to factor out the GCF. If you want, you can solve this by quadratic formula if you want. All right, so then I notice this is factorable. So I'm going to continue to factor this. Still have the 3 on the outside. So I have x and x, 7 and 1, and it's minus minus. That gives us negative 8. T-chart, nothing's going on over here because this doesn't make sense. 3 equals 0. We get x equals positive 7 and x is equal to 1. So remember, these are your zeros. These are your factors. Remember, your zeros are where it crosses the x-axis. Okay, so let's take a look at number 3. All right, so number 3 is an exponential equation. I have different bases, so remember I want to get the same base. So I could write 36 with a base of 6. 36 is 6 squared. And I have to raise my 36 in a negative x power. So this power to a power, we multiply the powers. So now that they have the same base, we can set the exponents equal to each other. So negative 2x equals 2 minus 3x. Add 3x to both sides. X is equal to 2. All right, let's take a look at number 4. Number 4, I need that graph there. So number 4 says, find the remainder if f of x, which is the function, and my function is this graph here. Find the remainder of f of x when I'm dividing by x minus 1. So I don't have the actual function to do long division, but I can use my graph. All right, so I'm going to take my divisor, and I'm going to pretend like that's my factor. And I'm going to add 1 to both sides. This will give me my 0. X is equal to 1. So I use the graph. So I want to know what's y equal to. This will be my remainder. This is always, all the time. All right, so go when x is 1. So here's x is 1. Go down. So you hit the graph right here. Go across. Negative 9. Negative 9. So my remainder is is negative 9. So if I had the actual function, I did long division, I would end up at negative 9 at the end. All right, number 5, it says to solve by completing the square. All right, so I have x squared plus 16x plus 21 equals 0. So remember, you always want to make sure your leading coefficient here is a 1, and it is. So I'm going to minus 21 first. So now I do half of 16, which is 8. Square it, 64. Add that to both sides. So on the left side we factor. Remember, we get the same parentheses squared. On the right side I'm going to get 43 when I add them. So this is x plus 8. Remember, the number that goes inside is always the number you got when you did half of the middle term. It's the number you're squaring. So we're going to finish this up, square root both sides, get rid of the square. Remember, it's plus minus in front of that square root. Now minus 8 over x is equal to negative 8 plus minus the square root of 43. Okay, so let's take a look at number 6, which is the radical equation. So as long as the radical is isolated, the square root is isolated, you could just square both sides. So my radical is isolated. And since it's a square root, we're going to square both sides. If it's not isolated, you just have to make sure you isolate first. All right, so I get 2x minus 7. X minus 3 squared means to do x minus 3 times x minus 3. So I get 2x minus 7, double distribute, x squared minus 3x plus 9. So I get 2x minus 7. I'm going to clean up the right side, combine like terms. It is a quadratic, so make sure it's equal to 0. So minus 2x, add 7. 0 equals x squared minus 8x plus 16. All right, so now I'm going to factor this. So I get x minus 4 times x minus 4. T-chart. So we get the same factors, same roots, same zeros. X equals 4, x equals 4. And you have to check it. So always plug into the original. So it's 2 times 4 minus 7. Does that equal 4 minus 3? Yes, 1 equals 1. You could just plug this into the calculator. 1 equals 1, and that works. Okay, so the next one is number 7. Okay, which is solving. Obviously, hopefully you can tell that this is set up using the quadratic formula. So x is equal to negative 4 plus minus. We plug in what's underneath the square root symbol. We get negative 64 over 2. So I get negative 4 plus minus. Now remember, the negative under the square root becomes an I. So I have square root 64i. So that's 8i. And then remember, you're going to reduce this, make the heart. So x is equal to negative 2 plus minus 4i. Okay, and the last thing, always make sure that you know your transformation rules. And make sure you know when a fraction is undefined. That's when the denominator of a fraction is equal to 0. Okay, so that's it, and I will see you in class tomorrow. Have a good night.